In this video, we're going to go over how to solve exponential equations. So we are going to use this property of equality for exponential functions. So what happens is if you have the same base being raised to different exponents, that means the exponents are the same. So b to the x equals b to the y means that x has to equal y. So you can see here in this problem we have 3 to the x equals 3 to the 5 has to mean that x equals 5. So let's use that idea to solve this problem given here. So we have 3 to the x equals 3 to the 2x minus 5. So what that means is we're going to take the exponents, x and 2x minus 5, and set them equal to each other. So now this is just an algebraic equation you can go ahead and solve. So I'm going to solve this by moving all my variables to one side. So in order to do that, I'm going to go ahead and subtract 2x from both sides. And when I subtract 2x from both sides, I get negative 1x equals negative 5. So now all I need to do to solve for x is to go ahead and divide both sides by negative 1. When I divide both sides by negative 1, I get x equals 5. So when you're solving exponential equations, sometimes you'll have to rewrite the problem so that the bases are the same. So you can see in this previous example, the bases were already same. But sometimes we have to do a little bit of rewriting. And to do this rewriting, I've given you a squares and powers chart that's linked in the course, and it can be very helpful when doing this. So you'll see that chart has one page full of perfect squares. And the next page, it has a list of commonly used powers that we can use to rewrite some of these problems. So for example, if we're solving 2 to the x equals 256. Well, 256 at first glance, you may not be able to tell that it's a power of 2. But if we look at our chart, you can see that 256 is actually 2 to the 8th. So let's go ahead and use that to rewrite this problem. So now we have 2 to the x equals 2 to the 8th. And now we can just solve it like we did the previous problem, right? We can set the exponents equal to each other, so we have x equals 8. So now you can go ahead and pause the video and try doing this example on your own. So here we have 4 to the 2x minus 1 equals 64. Once again, if we use the powers chart, you can see that 64 can be rewritten as 4 to the 3rd. So that means that we can say that 2x minus 1 is equal to 3. And then we go ahead and solve for x by adding 1 and then dividing by 2, so we have x equals 2. So now let's try this example. So you can see here we have 9 to the 2x minus 1 equals 3 to the 6x. So in our chart, we can see that 3 squared is equal to 9. So we can go ahead and rewrite that 9 as 3 squared. So we have 3 squared to the 2x minus 1 equals 3 to the 6x. So what you may be wondering is how we're going to go ahead and work with this left side. Well, notice what we have here is that something is being raised to a power, and that's being raised to another power. So we're going to use that very important exponent property that a to the m to the n equals a to the m times n. And that's going to allow us to go ahead and multiply those exponents together. So we're going to multiply that 2 and the 2x minus 1. So when we do this, we're going to distribute 2, and that's going to give us 4x minus 2. Okay, so we get 3 to the 4x minus 2 is equal to 3 to the 6x. Now what we can do is we can go ahead and take the exponents and set them equal to each other. So we have 4x minus 2 equals 6x. So now we just need to go ahead and solve this algebraic equation. So you can either move the 4x to the right or the 6x to the left. I think it's going to be easier if I just subtract 4x from both sides. So I'm going to go ahead and do it that way. So that's going to give me negative 2 equals 6x minus 4x, which is 2x. Now we need to get x by itself. So in order to do that, I'm going to go ahead and divide both sides by 2. When I divide both sides by 2, I get negative 1 equals x, and that is the solution. So now you can go ahead and pause the video and try doing this example on your own. So here, once again, we're going to use our powers chart, and that tells us that 125 is 5 to the 3rd. So that means we have 5 to the 5x equals 5 to the 3rd to the x plus 2. Once again, like we did in the previous problem, we're going to multiply those exponents, so we have 5 to the 5x equals 5 to the 3x plus 6. So we have 5x equals 3x plus 6. Just go ahead and solve by subtracting 3x from both sides. So we get 2x equals 6. Divide both sides by 2, and we get x equals 3.